السلام عليكم ورحمة الله وبركاته والصلاة والسلام على سيدنا محمد وآله وصحبه أجمعين. In this video, we will have an introduction, a brief introduction about strong and weak acid and base. Okay, let's start from this picture. As we see here, we have an acid which is HA, and this acid, this is before making a solution of this acid, and this is after making solution. So when we put this acid into H2O and to try to make a solution of this, so what is the difference between the acid before and after? So let's see here we have a molecule. This is a molecule of the acid. Okay, and then we will put this acid into H2O. Okay. Here we can see that there is no molecules here. We can see all the molecule will be separated into their component, so it means it will be converted to ions. So all the acid will convert it to ions. Okay, we'll have H plus and A minus. Okay, what about the other acid here? We have HP and acid, and again, this is before we have molecules here. Okay, this is the molecules of the acid. We will put it in H2O. So, we have a big difference here because we still have molecules, but small part only that dissociate to their component, small part that form ions. So we still have molecules, we have a small number of ions inside the solution. And this is the difference between strong acid and weak acid. So strong acid will completely dissociate to form ions. So all the molecules will form ions in the solution. But for weak acid, only small part of the molecules will form ions and the other molecules will be stays as a molecule. So you can find only small part as an ion. Okay, let's see here. So what is the strong acid? So strong acids, the acid will be completely dissociate into their ions in water, like HCl. This one will convert it to H plus and Cl minus. Okay, and here we should write it like this: HCl, H plus and Cl minus, but we know that the equilibrium here lies far to the right. It means we have only product, we don't have any reactants. That's why we don't have a reverse. So we will write it only as an one arrow. Again, so for a strong acid, we have only product. After making this equation, the solution of this one, we have only products. We don't have any reactants. That's why it's only one arrow. It's only one direction. It's because it's a complete reaction. Okay, so why this one is a complete reaction? This is the acid here, and this is the conjugate base. Okay, so the conjugate base here, it's an base, so this base should attract the hydrogen again and form the reverse reaction. But because this one is so weak, so this one can't attract the hydrogen, can't combine with the hydrogen again and form the reverse. So why we don't have a reverse reaction? Because the conjugate base for this acid is so weak, it can't make the reverse reaction. Okay, so how to know that this one is a strong acid? We need actually to memorize the most common strong acids, and they will be the 7th acid here. Okay, HClO3, HBr, and so on. So you need to memorize these acids. Any other acid will be a weak one. Okay, their solutions should be a good conductor. So how to be a good conductor? Again, you should have one of these. Any solution to be a good conductor should have ions inside the solution, because these ions will carry the electricity between one electrode to the other electrode. So because we have a huge amount of ions in this solution, so it can be a good conductor. Okay, weak acid will never completely dissociate in H2O like HF. In this one, we have a reverse reaction because it forms H plus and F minus, and inside the solution, so let's see inside the solution, let's take two solutions. It says that this is a solution of HCl, so we have plus and negative ion, plus and negative ion. There is no molecule. But if we're taking the HF, we will still have a molecule, and we will have F minus and H plus. Okay, so this is the difference here. Inside the strong acid solution, we have all ions. Inside the weak acid, we have molecules and we have ions. So we have both product and reactants. That's why we still have an equilibrium. But the huge amount will be reactants. That's why we will say that the equilibrium lies far to the left. So it means we have more reactants than the product. Okay, so why we have a reverse reaction here? We didn't have it in the strong acid, and the strong acid didn't perform the reverse reaction. Why this one will perform a reverse reaction? This is a weak acid, and this is the conjugate base of the weak acid. So again, Who we will do or make the reverse reaction, the conjugate base, because this conjugate base comes from a weak acid, so it's a strong conjugate base. So this strong conjugate base, it will easily attract the hydrogen from the solution and form the reverse reaction. Okay, so that's why we have a reverse reaction here, because it has a strong conjugate base. Okay, let's compare between the conductivity of a strong acid, sorry, not base, strong acid, and weak acid. Okay, as we said, in strong acid, we have a huge amount of ions, so they will conduct electricity. That's why it's a good conductor. But for weak acid, we have small amount of ions, so it will conduct electricity, but actually it will be a weak conductor. It's not like the strong acid, because the number of the ions will be low. Okay, so what about strong base? Again, strong base will be dissociate completely in H2O, but they will produce hydroxide ion, not hydrogen or hydronium like an acid. Like if we have an OH, and this will be a unique compound, so it's a solid. When we dissolve this one H2O, it will form Na plus OH minus. So here, this one will be completely dissolved in H2O to form ion. So again, it will be completely dissolved. So don't have an equilibrium here. We have only one reaction, because this one is a complete reaction. Okay, so we have a huge number of ions inside the solution. We don't have any OH as a solid or as a compound. Okay, the strong base, the base should contain hydroxide ion. So to produce hydroxide ion inside the solution, when dissociate, so they should have hydroxide ion like NaOH, like LiOH, like KOH, like so any CaOH2. Okay, so you will consider that all the bases that contain hydroxide will be a strong base. And we will talk in detail later about how to consider CaOH as a hydroxide strong base. But all the bases that will produce hydroxide ion in the solution, so this will be this base will be considered as a strong one. So we will have only huge amount of iron inside the solution. So if we want to compare their conductivities, it will be a good conductor. What about weak base? Weak base, they don't contain hydroxide ion. So weak bases, they don't contain hydroxide ion. But when they dissolve in H2O, they will produce hydroxide ion. Like in H3, this one doesn't contain hydroxide ion, but when dissolved in H2O, according to Bronsted-Lowry, this one will attract the hydrogen ion, so it will form NH4 plus OH minus, because again, we know that H2O is OH minus and H plus. When we're taking the H plus, so we will have OH minus. So according to the dissolution process, or dissolving this one in H2O, it will form hydroxide ion. That's why we will say that the solution of NH3 will be a basic one. Okay, so all the weak base, they don't contain bases, don't contain a hydroxide ion, but when dissolved in H2O, they will produce hydroxide ion. And these will be the bases which contain nitrogen or amine, like CH3 and H2, or C2H5 and H2, and so on. So all these bases, they contain nitrogen or amine group, so they will take the hydrogen from H2O, and this will produce hydroxide ion in the solution. But here again, if it's a strong one, again, if it's an acid base, it's only one complete reaction. But here we have an equilibrium, because this is the base here, and this is the conjugate acid, and the conjugate acid can make or perform the reverse reaction. Okay, so all the weak acid or base will have our equilibrium. We will have forward and reverse, but for the strong, we have only one direction, we have only one reaction.